This is lesson 2.8, dividing integers. You can use counters to model division of integers. Follow these steps to find -8 divided by 2. Place 8 negative counters on the mat. Then separate the counters into 2 equal groups. There are 4 negative counters in each group, so -8 divided by 2 is -4. Find each quotient, which is the result of division. Quotient is the term used for the result of division, using counters or a drawing. In example 1, -6 divided by -2, I have -6 counters on the mat. I've divided them into groups of 2, so my resulting quotient then is -3, because I have 3 counters in each group. In my second example, -12 divided by 3, I have 12 counters on the mat divided into groups of 3, so -12 divided by 3 is 4, because there are 4 counters in each group. Actually, it's -4, isn't it? Division of numbers is related to multiplication. When finding the quotient of 2 integers, you can use a related multiplication sentence. So in the multiplication sentence, 2 times 6 equals 12. I can then write the inverse of that as a division sentence. 12 divided by 2 equals 6. So the factor in the multiplication sentence, is the quotient in the division sentence. 4 times 5 equals 20. Translates to 20 divided by 4 equals 5. So this factor here becomes the quotient here, because multiplication and division are inverse operations and they undo each other. Since multiplication and division sentences are related, you can use them to find the quotient of integers with different signs. That means one's positive and one's negative. So 2 times -6 equals -12, which then translates to -12 divided by 2 equals -6. So negative factor here, negative quotient here. -2 times -6 equals 12, because remember, a negative times negative is a positive. The related division sentence is 12 divided by 2 equals -6. This factor becomes this quotient here. These related sentences lead to the following rule. The quotient of 2 integers with different signs, that means one positive and one negative, is always negative. 2 integers with different signs, the quotient is always negative. Dividing integers with different signs. 80 divided by -10. The integers have different signs. 80 divided by -10 is -8, so the quotient is negative. With 2 numbers, a divisor and a dividend, with different signs, the quotient is always going to be negative. In number 2, find -55 divided by 11. The integers have different signs again, one positive, one negative, so -55 divided by 11 equals -5. In the check your progress examples, we would write 20 divided by -4 equals -5. In B, -81 divided by 9 equals -9. -45 divided by 9. 2 numbers with different signs always give us a negative quotient. In this case, it's -5. You can also use multiplication and division sentences to find the quotient of integers with the same sign. In our first example, they're both positive. 4 times 5 equals 20. So 20 divided by 4 equals 5. The factor here, again, becomes the quotient over here. Our second example, negative 4 times 5 equals negative 20. So negative 4 divided by, or negative 20 divided by 4 is negative 5. The factor here becomes the quotient over here. These related sentences lead to the following rule. The quotient of two integers with the same sign will always be positive. The quotient of two integers with the same sign is always positive. Here we have 2 positive, so our quotient is positive. Here we have 2 negative, so our quotient is also negative. Dividing integers with the same sign, both negative in number 3, negative 14 divided by negative 7. The integers have the same sign, so negative 14 divided by 7 is positive 2. Whenever the signs are the same, the quotient is always positive. In number 4, it says evaluate negative 16 divided by 4 if x equals 4. So your algebraic expression becomes a numerical expression. Negative 16 divided by negative 4, that's 2 signs that are the same, both being negative. The answer then is positive 4. Negative 16 divided by negative 4 is positive 4. In the check your progress problems, negative 24 divided by negative 4 gives us a quotient of positive 6. In E, negative 9 divided by negative 3 is positive 3. And T, negative 28 divided by negative 7, the answer would be 4, or the quotient would be 4. Like signs, positive quotient. 10 years ago, the estimated Australian koala population was 1 million. Today, there are about 100,000 koalas. Use the expression n minus p, where n represents the new population and p is the previous population, to find the average change in the koala population per year for the 10-year period. So, new population minus the previous population divided by 10 equals 100,000 minus a million divided by 10. Subtracting a larger number from a smaller number gives us a negative difference. In this case, negative 900,000 divided by 10 is 90,000. Check your progress. The average temperature in January for North Pole, Alaska is negative 24.4 degrees Celsius. Use the expression 9 times C plus 160 divided by 5, where C represents the average number of degrees Celsius, to find the temperature in degrees Fahrenheit. This chart shows us that with addition, two signs that are the same, we would always get a answer or sum that's the same as the signs. So if I'm adding 2 negative, I get a negative answer. If I'm adding 2 positive, I get a positive answer. Subtract absolute values. The sum has the sign of the integer with the greater absolute value. To subtract an integer, add its opposite. It's called the algebraic definition of subtraction. Multiply and divide, it says same signs. Same signs, the product or quotient is positive. Different signs, the product or quotient is negative. Check your understanding. Number 1, negative or positive 32 divided by 8, negative 8, is negative 4. Unlike signs, negative quotient. Number 2, negative 16 divided by 2, answer is 8. Negative 8, because we have unlike signs. Number 3, 42 divided by negative 7. This looks like an improper fraction. You could use it that way, but in this case, it's a numerical expression. 42 divided by negative 7. Different signs gives us a negative quotient. Number 4, negative 30 Negative 30 divided by negative 5. We have like signs. Therefore, we're going to have a positive outcome. Signs are the same. The outcome is always positive. Number 5. 55 divided by 11 is actually 5. 55 divided by 11 is 5. Let's fix this. This is too messy. Number 6. Negative 16 divided by negative 4, like signs, gives us a positive outcome of 4. Number 7. 15 divided by y becomes 15 divided by y becomes 15 divided by negative 5. Unlike signs means negative quotient. 15 divided by negative 5 would be negative 3. 8 would be xy divided by negative 10. Well, x times y, this means x times y. X times y is 8 times negative 5, which is negative 40, divided by negative 10, gives us an answer of positive 4. Unlike signs, or like signs I should say, like signs, negative negative gives us a positive outcome. Number 9, the lowest recorded temperature in Wisconsin is negative 55 degrees Fahrenheit on February 4th, 1996. Use the expression 5 times Fahrenheit minus 32 divided by 9 to find this temperature in degrees Celsius rounding to the nearest tenth. So 5 times negative 55 minus 32. This becomes 5 times 55 plus a negative 32 gives us 5 times 21, actually 23, which is 115. Divide that by 9. 115 divided by 9 is 1. 25 would be 218 and 7/9. Let's do it the correct way, like this. 9 goes into 11 once, bring down, goes twice, 18. Then 70 would be 9 times 8 is 72, so we got to go to 9 times 7, which is 63. Gives us a 7. That means this is going to repeat. It's going to be 12.7 repeating. 12.7 degrees repeating. At this point, you should stop watching the video, go to my Moodle page, and take lesson 2.8, log in using your 6-digit student number, and the first 6 letters of your last name, and your 2-digit birth date.